Hey guys, what's up? So, hopefully you're ready to make money because I am, and I'll teach you how. Get ready to learn something useful. So, I'm Mr. Ray the teacher. There's my social media. Don't forget to subscribe, hit like, and click the notification icon to be in the loop. Become smarter for a brighter future. Moving on. So, economics, my bread and butter, subject I'm actually qualified to teach. Officially, it's on my license. Supply and demand's the topic. The concept will be price elasticity, hence my really good elastic band I draw in paint. Elastic and inelastic demand. You're going to get a quick rundown. And yeah, it's a metaphorical elastic band if you didn't get it. So hopefully you do get it. I'm pretty sure you do. Anyway, with that, elastic and inelastic demand, price elasticity is where we use the metaphor of price being like an elastic band. It measures how sensitive the quantity demanded is relative to changes in price or quantity supplied. So here's my elastic band, it's a rubber band if you really don't get it. Be careful with wording. Demand does not change, the quantity demanded changes. Anyway, perfectly elastic demand means if price changes at all demand drops to zero. Elastic demand is when the quantity demanded for a good significantly changes when prices either go up or down. So these graphs are flatter. So for example, more expensive things like luxury goods to the average Joe. Unitary demand is when the quantity demanded for a good changes unitarily at the same rate. University, somewhere you might be or aiming to be. College for those in other parts of the world. Whatever. The change is in direct proportion. This graph is always at 45 degrees to the x-axis. And inelastic demand is when the quantity demanded for a good does not change much when prices go either up or down. These graphs are steeper, and perfectly inelastic demand means no matter what the price change, demand remains constant. So flatter and steeper, gradient, if that brings back a bell to you. Gradient, or walking up a hill, a steep hill. Yeah, just gradient. So here are the formulas. If percentage change in quantity over percentage change in price. If it's infinite, it's perfectly elastic. This triangle here, delta change, okay? You can write percentage triangle Q, percentage triangle P for your formula. We get it. Same thing, if it's over 1, it's elastic. If it's equal to 1, it's unitary. Look at that color. If it's less than 1, it's inelastic. And if it's 0, it's perfectly inelastic. Now, same thing, we could do this one. 3, 2, 1, clickety-click. Supplied. And clickety-click. Demanded. It's the same if you're trying to work it out. So here's a hypothetical table. A lot of data here, a lot of math. So for your accountants in the making or people that are just scared, have a phobia of numbers, well, toughen up. You'll be sweet. I've rounded these off. These are infinites, by the way. So just rounded it off. Here you go. If I put it in color, it's probably easier to understand. So you're looking at here. So looking at the prices here. So it's from $10. It's not really changing price. $9, $8, $7, $6, 5, 4, 3, 2, 1. The quantity, it's changing and all that. Your total revenue. That's just all the multiplication. So let's look at here. Change in price. We'll show you an example. So it's going down $1 from $9. From $10. So it's gone down $1. So here's the math. 9 minus 10 equals minus 1. And that's how we got that particular number. Let's look at this number here. Another minus 1 change in price is the result, because if you're coming down from $4, so 3 minus 4 equals minus 1. And this is where I got the numbers if you really didn't get it. These two numbers here. It's changing. How much are we changing by? At what rate? Percentage is just merely a percentage calculation. So there you go. There's the working out. And that's how I get it. So from these bad boys, divide, get that, move it there. And this one again. So for example, minus $1 divided by 6 equals what it does. Now remember that when you're doing a percentage means out of 100, so you got to move the decimal point 2 places to the right. And that's how we get that particular percentage. Now repeat the same steps, and that's how we get those percentages using those ones. Now, elasticity of demand is change in quantity percentage demanded divided by change in price percentage. And let's look at this one here. So the purple boxes now, and if that wasn't too clear, we're getting that number here and that number here. So 12.50%, 12.5% divided by 50 equals minus 0.25, minus negative 50. Now remember the gradient going down. Now when you're looking at elasticity of demand, we do get it. Demand pretty much always goes down. So you just need the number. So minus means the gradient is going down. You should have learned that in mathematics. We only need the number itself. And as the elasticity of demand is less than 1, because 0.25 is lower than 1. So if you look at these ones here, that number is 9, that's a 4. 1 is perfectly unitary. Now we're getting lower and super low and super high on the extremities. Therefore, the demand is inelastic because, as I said, elasticity is lower than the number 1. So here's some quick basic math. The formula for elasticity of demand is this. And here is my graph that I've prepared earlier. So at these following price points, at $8, you're getting that much quantity. At $7, at $6, at 5, at 4, at 3, at 2, at 1, 0. And I've just drawn a straight line going down at 45 degrees. So there you go. If you're wondering why the x-axis hasn't been filled out, wonder no more. I'm wondering too, actually. That's worrying. Anyway, the topper end of the field, elastic, because elasticity of demand is over 1. Unitary elastic smack bang in the middle, and inelastic is down the bottom. So there's the table from the previous slide. It's a bit small. If you're looking at this at home, good. You can probably focus in on it more. If you're looking at this in class, it's going to be in for a struggle. Anyway, change in quantity and price over change in quantity percentage over percentage change in price. So let's look at $8. So look at that. We just input the numbers from here. So that's where we get the minus 1 from. That's where we get the 2 from. That's where we get the minus $1 from. That's where we get the 8 from. And with regard to units of measurement, not too picky. Just make sure that you've picked the same type. So if it's 50 cents, and on the bottom, for example, here is $8, make it $0.5. So here we go, basic math. Hopefully, if you've made it to college, university, you can do this. If not, I've got videos on that too. Check them out. So there's your minus 50. There's your minus 12.5 equals 4 over 1 equals 4. So it's elastic because the elasticity of demand is a number higher than 1. So at $8, it's just... So elasticity of demand can be drawn on a graph easily, and visually identifying it if a good has inelastic or elastic demand properties is surprisingly easy. So remember, when you're drawing a graph, x-axis, x is across, it goes across, and y, see that line going down, vertical? Easy. So price on your y-axis, quantity on your x-axis, in a left-right direction, demand goes down, and now here's another one, another demand curve, and here's another demand curve. Now just look at it real quickly. I'm just gonna give you the chance to pause the video if you really want to. Which one's inelastic, which one's elastic, and which one is unitary? 3, 2, 1. Well, here's the secret. Thank me later. It's gonna be mind-blowing. I copyright this. Unitary elastic demand, 45 degrees. Inelastic demand, look at this. Ta-da! Inelastic demand, that's the letter I, or looks like it, a messy one at that. And elastic demand, ooh, that's the letter E for elastic demand. Oh, mind blown. Fantastic. Très magnifique. And I'm impressed. I impressed myself. Here the slope is steep. Just try imagine walking up a hill that steep. We're climbing up it. And here it's pretty gentle. Walk it up easily. So slope, the gradient. Here we go. If it's going to be perfect, then perfectly inelastic. And looking here, it's perpendicular to the x-axis. And here is an E for elastic demand, perfectly elastic demand. And here it's parallel to the x-axis. So remember, perpendicular and parallel, different. Okay, or I could have said it is parallel to the x-axis. That's another one. Okay. I'm still amazed at this. Now, when demand is inelastic, a decrease in price will decrease total revenue. So here's the proof. Inelastic demand, the slope is steep. So look at this price going here. And look at that quantity. If you don't get how that works, check out my other video. And it explains it more, supply and demand, movements and shifts. Check that video out. And look at price 2, quantity demanded 2. Now look at that first box. Now look at this second box. And if it doesn't make sense for you, it will. Because the gain in revenue from selling more quantity, because look, you are selling more. You are selling more. So look at that. That's the gain in revenue. Now I'm not saying gain in total revenue, it's the gain in revenue. What you're going to get more. Now let's compare that with, so you're gaining this much, compare that, is less than the loss in revenue because of the lowered price. So look, gain this much, lose this much. This one here, this green box here, that stays as is. Who said math didn't apply when you reach senior college? Anyway, here we go again. When demand's elastic, a decrease in price will increase total revenue. So there's my elastic demand. Copyright that idea. The slope is gentle. So look at here. Original price, original quantity, price 2, quantity 2. So here we go. Now, with that, the gain in revenue from selling more units. So you gain this much. Is more than the loss in revenue because of the lowered price. So you lose this much. So just do a good comparison. Which one's getting more? Look at this. The yellow square should be smaller. And if it's unitary, it's about on point. So when demand is unitary, so you're 45 degrees, unitary elastic demand. At higher price points, the response will be the same as if the item was elastic. So I got to correct, I think, what I said like maybe 30 seconds ago. So sorry for that little misstep, but here, take this one as gospel. So look at the price here. Look at the quantity, price 2, quantity 2, comparing the boxes. So remember that you lose this, gain this. Overall, you gain more. We good? No one mind bended? No one's mind exploding? Bear with me. At lower price points, the response will be as if the item was inelastic. A decrease in price will decrease total revenue because the gain in revenue from selling more quantity is less than the loss in revenue because of lowered price. Okay, so the gain in revenue from selling more quantity is less. You don't want that. You want more. More is good. Greed is good. Remember, we're not charities. We're businesses. We're here to make money. So P3 gets you quantity demanded 3. P4 gets you quantity demanded 4. Same thing, comparing the two boxes. So you're going to gain that much, lose that. So you're going to lose all that. You're only gaining this purple box. Overall, you lose more. Not good. There is a sweet spot in the middle. I kind of hit skip too quickly, but here we go. There is our table from ages back. If you're looking on the computer, super easy. If not, you're going to have a hard time. Now, with the other slide, I know I didn't have the numbers, but here I've got the numbers for the x-axis, but it's pretty much as is, 1 up to 10. Unitary, it's changing. Stable, as you can see here, it's only changing, -1. If you didn't get it, so at $10, you sell 0, $9, you sell 1, at about that much going down, down, down. At $1, you're selling 9, and at $0, well, you would sell 10, but you'd be giving them away. Anyway, just for argument's sake, we put that there. Have our little laugh. There's our straight line joining up the plots. It's a line graph. Now, there you go. Let's plot that here. So at $8, you're selling 3. Oh no, at 2. At $7, you're selling 3. At $6, you're selling 4. At $5, you're selling 5. So in this sense, you are making money, and the gradient would be going like you're going up a hill, okay? Going up. So making money, that's good. And from $4, you'll sell 6, but your revenue is going to be going down for sure. And you can cross-reference that at the bottom. At $2, you'll be selling 8. So it's about 16 bucks you make. 2 times 8. At $1, you'll sell 9. So you're selling heaps. But you're only making $9, so you gotta wonder where your priorities are. And 0. Anything multiplied by 0 equals 0. There is a sweet spot in the middle where you would want to stop making more. There's my little curve with my rainbow line. The things you can do with PowerPoint. If you didn't know, I made this on PowerPoint. So you should have an arc that looks like a mountain and is perfectly symmetrical. And you can clearly see returns, especially diminishing returns. And once you hit the point of no return, the apex, negative returns. So in the sense you are losing money, and that is not good. So here you've got elasticity of demand being over 1, unitary elastic, and here is inelastic demand, right? And here are things like MR equals 0, because remember, the math, the gradient, rise over run. So change in y over change in x, and of course our y-axis is price, our x-axis is quantity. You are looking at the change in y with respect to the change in x. So that's why. So what did you learn today? In summary, if that's what someone asks you, please don't waste a taxpayer dollar. If you go to a public school, here's your answer. Elastic and inelastic demand. Price elasticity is how sensitive supply or demand is to price. It's likening it to an elastic band. The more elastic something is, the more sensitive it is to price changes. Conversely, the more inelastic something is, the less sensitive it is to price changes. So an example for elastic would be, for example, expensive things. Inelastic would be, for example, bad cigarettes. Because, like, for example, Australia, they're 40 Australian dollars for a packet at time of recording. That's a decent ballpark price, give or take $5. Want to go to the cheaper brand, give or take $10. And back many years ago, like, we'd be going, oh, it's going to hit $1 a cigarette. That's probably when you should quit. Many people have, many people haven't. Price deterrent. But the bottom line is, if you're addicted, you're addicted. Same thing tends to go for illicit drugs. I'm not supporting the use of them, just giving you a real world example, because like desperation can kill, literally, especially people that want drug money. There's the formulas, if we really need to. We've gone through that long enough, so I'm not going to read that again. So let's wrap things up. Thank you for watching. Please subscribe and check out my other videos. Spread the word to your classmates, friends, fellow colleagues. Check out my Patreon. Feel free to support me if this video helped you out. And if you watch the ads, if this video is monetized, mucho gracias. And also special thanks and shout out to the following. So Yui and Action Man and Pam for helping me out. So fellow teachers and my buddy that's studying accounting that asked me to make this video. So help her out. Good luck. And yeah, we'll catch you on the flip side. Remember to study hard for a bright future. Ciao.